Hi, welcome to my very first YouTube video. I'm going to get into an intro to systems of equations. So a system of equations has two and sometimes more equations with two and again, sometimes more variables. So for the purpose of 8th grade in Algebra 1, most of your equations will just have x and y as the two variables. And you'll just be working with two equations. So looking here, we have the two equations y equals negative 2x plus 1. And then we have y equals x minus 5. The equations above form a system of equations because there are two equations with two variables. So the two equations are also in slope-intercept form, y equals mx plus b, so these two equations here. I did that because this is an intro, so I'm going to try to keep it simple just to start off with. And I'm going to warn you guys, they are going to get a little more complicated as we progress. So therefore, we can solve the system of equations by graphing both lines on the same coordinate plane. Now, where the two lines intersect is going to be our solution. So, looking at page 46 of your binder, go ahead, if you don't have your binder, pause this video and grab your binder and open up to page 46 because I'm going to be referring to page 46. So step 1 for the very first equation, y equals negative 2x plus 1. Step 1 on page 46 tells us to identify the slope m and the y-intercept b. So I like to think of m as the number with the x and b as the number by itself. So the number with x, which is my slope, is going to be negative 2. And the number by itself, b, is 1. Looking at the sub-step of page 46, on step 1, it says the number for m, which is negative 2, should be a fraction because we need to rise and run. So since this is not a fraction, I'm going to put a 1 under. So this tells me that I am going to rise 2 times and then run 1 time. Now step 2 tells me to plot b on the y-axis. So b is 1. So here's the y-axis. I'm going to plot b on the y-axis. So here's the origin 0, 0. So that tells me that 1 is up here. And now step 3 tells me to plot additional points using our slope m. Now this is a negative slope, negative 2 over 1. So I'm going to be looking at the negative slope rules, which tells me to rise up 2 times and then run left 1 time. So I'm going to be going up 2, left 1. And those are the rules on the negative side. So up 2, left 1. And you just keep it going. Up 2, left 1. Up 2, and then left 1. Now there's no more space to plot additional points that way. So looking at the second step that I wrote on the negative side, it tells me I can rise down and run right. So I'm going to go down 2, right 1. Now I'm going to go back to B, because that was where I began, and I'm going to go down 2, right 1. Down 2, right 1. Down 2, and then right 1. And I'm going to go ahead and now get a line and connect those points as best as I can. And that did not go perfectly through all the points, so I'm going to go back up and kind of edit that line. Looks like right there. Maybe that's as best as I'm going to get. All right. Now I'm going to go ahead and use red for the second equation, and I'm going to go ahead and erase this information. I hope you had it written down somewhere on a separate piece of paper. I am going to go ahead and do the same thing now, but with the second equation. A lot of you guys emailed me with questions like this that you guys were working on iExcel. Now, if there's no number in front of the x, you can imagine it as a 1, because technically there's 1x there. So that means that my slope m is 1, and the number by itself, b, is technically negative 5, because we think of this minus sign like a negative. And once again, looking at the sub-step, I need a fraction for my slope, so I'm going to put a 1 under there, so over 1. And that tells me that I'm basically going to rise 1 and run 1 as well. So step 2 tells me I'm going to plot b on the y-axis, so now b is negative 5. So here's the origin, so negative 1, negative 2, negative 3, negative 4, and negative 5. So I'm going to plot negative 5 on the y-axis. And I'm going to use my slope 1 over 1 to plot additional points. So that's step 3. And again, this is a positive slope. So I'm looking at the positive slope rules, which tell me I can rise up and run right. So up 1, right 1. Up 1, right 1. Up 1, right 1. Up up one, right one. Up one, right one. And you could keep going, but just for the sake of time, I'm going to go back to B and go the opposite way. So looking at the positive slope rules, you can also go down and left. So down one, left one. Down one, left one. But as you guys can tell, right here would be where they intersect. So I'm going to go ahead and get a line to connect those points as best as I can. Looks like right about there. Let me see if I can get a little bit better. All right, so I'm going to go ahead and use green for this point right here where they intersected, and the coordinates for that point are technically 1, 2, and then -1, -2, -3. So let me go ahead and circle this for you guys. Okay, I used the mouse for that. That worked so good. So that's the point where they intersect, and the coordinates are 2, -3. So that technically represents our solution. So our solution is the point 2, -3. Now, wherever the two lines for the two equations intersect is going to be our solution. And what that technically means algebraically is this point, 2, -3, will balance out both equations. So what that means is that when x is 2 and y is -3, both of these equations will be balanced out. So I'm going to go ahead and show you guys what the first equation. So the first equation was y equals -2x plus 1. Now, when I plug in 2 for x and -3 for y, they're going to balance out. So just to remind you guys, the first number is always for x in a point, and the second number is always for y. So y is -3. I'm going to plug that in. And then we still have -2. And -2x means -2 times x. So now x is 2. So times 2 plus 1. And now we're going to do some simple math. And going back to like 6th grade, PEMDAS comes first. So -2 times 2 is -4. So this becomes -4 plus 1. And everything else in our equation stays the same. And now just addition, -4 plus 1 is -3, which shows me that the equation is balanced out when x is 2 and y is -3. So same thing with the second equation. The second equation was y equals x minus 5. So once again, when x is 2 and y is -3, our equation will balance out. And I'm going to prove that to you guys now. So y is -3, and then for x, I'm going to plug in 2. And now we're going to do some simple subtraction. 2 minus 5 is -3. So once again, even this equation is balanced out. Now, keep in mind for my next video that where the two lines intersect is the solution. So here, these two lines for the two equations intersected at 2, -3. So that was my solution. Now, the lines will not always intersect. So keep that in mind. And sometimes they might even end up being the same line. So those are going to be two different scenarios. The lines never intersecting and the lines technically being the same. So they're always intersecting, which I'll get into in the next videos.